Good afternoon and good morning, everyone, and thank you very much for being with us again in another SolarPower Europe webinars. Today we are going to discuss how a digital-first approach can improve utility-scale solar project economics. I am Merce Labordena, and I am the Senior Policy Advisor at SolarPower Europe, where I coordinate the work stream on digitalization. And today with me, there are two speakers, Miroslav Petkov, who is the team leader of the solar design at ABO-Wind, and Olivia McShea, the head of sales and marketing of PVComplete. And they are the experts who are going to bring light today on how this digital-first approach can improve the economics and the bankability of utility-scale solar projects. After their interventions, we will have a Q&A session. So, of course, feel free to send us your questions in your box at the right, where you can just type there the questions, and then during the Q&A, I will read them out loud and share them with the speakers, and the experts can answer these questions. So feel free to, as long as we move ahead with the webinar, to put your questions there, and then I will bring them on at the end. Perfect. So without further ado, I would like to introduce first to the problems on stake that we are going to cover today. And it is that when it comes to utility scale solar project development, we of course need to make a very careful analysis to ensure that project economics has never been more critical to mitigate the risk, also to ensure project bankability and to realize the returns. The good news, though, is, as we are going to see today, is that project developers, they have now the project powerful new digital tools at their fingerprints to quantitatively inform their portfolio decisions. So during this webinar, we are going to try to answer some questions, like what are the most important factors to consider during the project design, as well as how can we increase the speed and the accuracy of both the preliminary site assessment and the design optimization. Miroslav Petkov, the team leader at solar design at ABO-Wind, will bring more light on the issues at stake.
Thank you, Merce. Hello, everybody. My name is Miroslav Petkov, and I'm the team leader of the design team of ABO-Wind. Before starting with the main subjects of my presentation today, let me briefly give you some information about the company, so you better understand the perspective from which I will be giving my presentation today. The company was established in 1996 by the two owners and founders, Dr. Jochen Ahn and Matthias Bockholt. Since then, ABO-Wind has grown steadily along with the renewable sector. The company's founders are still main shareholders and still managing the company. We develop solar and wind farms in 16 countries around the world in 4 continents. ABO-Wind is a globally successful project developer for renewable energy with more than 600 employees. And since the company was established, it developed solid wind, solar, and biogas projects with a total output of 3 gigawatts. Half of them are turnkey projects, out of which more than 80% in operation and maintenance. We are currently working on the development of new projects with a total capacity of 12 gigawatts, again in 16 countries and 4 continents. Here you can see basically the countries where our company is active. Of course, we are not active everywhere, but where the company establishes relationships, it's always in a long-term perspective. Okay, talking about project development, solar projects, here are the main topics that I will try to cover today, starting from the main criteria related with the energy use estimation, and of course the digital tools available for doing this, going to the terrain evaluation, and giving you some brief real site impressions. When starting development of a solar project, of course, from crucial importance is a proper energy potential estimation. For serving this, there are a number of software tools on the market. So the main criteria here is the meteorological data that is available. We try to compare and to briefly show you the results of comparison of 5 different sources. Here you can see the deviation of the 5 different sources from the average that is valid for all of them, which immediately brings the importance of having a proper data source for accurate estimation, further estimation of the energy yield that can be expected. Once the energy yield is decided and available, there are several system parameters that are subject of optimization. Starting from the pitch optimization, of course, again, with the support of the software tools, we are able to run multiple simulation variants in order to get to the optimum pitch for a certain location of the project. The tilt optimization, of course, is the other factor immediately and going together with the optimization of the pitch. Nowadays, it is really convenient and suitable way for running multiple simulations to get the optimum parameters for these criteria. A comparison of different orientations and also modules technologies is shown in the table here. Of course, depending on the location of the site, it is always worth to evaluate the best orientation of the system. Otherwise, nowadays with the support of the software, it is a really quick process, but again requiring an experienced person running the software simulations, but otherwise it would be taking much more time to get a better understanding about the optimum yield. Of course, in the recent years, the bifacial modules are coming more and more spread on the market. So assessment of the bifacial gain compared to the traditional monofacial estimation is also part of the optimization that we are performing when deciding on project whether to go or not. Another important parameter that are part of the system assessment and parameters optimization, this is the DC-AC ratio. Here, of course, you can see different variants of the DC-AC ratio for the same project and respectively how it affects the total yield and the performance ratio of the system. This is helping us to make a decision on the best DC-AC ratio, but also working together with the finance to define the cost for obtaining the best DC-AC ratio and compared to the expected yield. Again, depending on the system location and the near shading objects, there could be also optimization of the azimuth required. And the example here, you can see 4 different projects where we run optimization of the azimuth, and the results, of course, are at first look could be a bit surprising, but it is really showing how 4 different projects in relatively close location can have a different optimum azimuth exactly because of the near shading objects. And this is very important step for us because we are always targeting to get the maximum from the system. After the meteorological data, the next criteria, which is from key importance for the project that we are developing, is of course the site conditions. On the next 2 slides, I will be showing you how it goes when we're talking about evaluating the site conditions with respect to the topography. So depending on the racking system that is going to be used, the terrain slope limitations are defined. And by using a proper software tool, we can relatively easy and quick define the exclusion zones. Here are shown in red color, of course, within the site boundaries. After this, again, we are able to run and to create a preliminary layout of the system, again, identifying the exclusion zones, so we can easily understand how much power we can install on the current location, and respectively taking into consideration the zone of the terrain that is not proper for installation of PV systems. Very important role here is again of the experienced engineer running the simulations to properly evaluate the results from the software. On the right side of the slide, you can see the background from the actual conditions on the site. And because it comes to show that sometimes the topography could be also showing tree or bushes like terrain deviations. So here is the important role of the person to properly evaluate this and respectively decide to include or not include this in the next layout. Yeah, here is a quick site impression for a relatively complex terrain, how it looks when built. Again, the same project. What is important here is to mention is that the terrain is changing its elevation in all directions. But anyway, the fixed steel system is following the topography of the terrain. And even in this project with the different slopes, and they were higher than 10%, to overcome this problem, we used 15 different tables configurations, which is also important for the economics of the project, of course. Here is another view from a single axis tracking system. You can easily see the difference when it comes to comparing fixed tilt and single axis tracker. The tracking system is requiring definitely flat terrain to be able to build there. Like some brief and important conclusions out of this is that I would say that using a proper software tool in combination with the skilled and experienced people is increasing significantly the speed and the accuracy of the preliminary site assessment and design optimization. This is giving us the opportunity to run multiple simulations in order to come to the optimized solution that we consider optimum for our project. The meteorological data that is used for the yield estimation is of course of crucial importance, as I was mentioning in the beginning, because wrong assumptions about this can kill a profitable project in the beginning, or vice versa, to give a green light to a non-profitable one. And of course, accurate topography is also from essential importance for the initial assessment of the project site. Again, the same reasons, if not proper topography or wrong estimation is run, it can bring to wrong conclusions, positive or negative, and of course, a negative output for the company itself. So thank you very much for your attention, and I believe you have time after that in the questionnaire session to discuss more details.
Thank you very much, Miroslav. That was very, very informative. Now we are going to go to the next expert, who is Olivia McShea, and she is going to present us a specific example of a project. Olivia, the floor is yours.
Thank you. Thank you, Miroslav. Really strong outline on some important considerations for these utility scale solar designs. Welcome, everyone. My name is Olivia McShea. I'm head of sales and marketing at PVComplete. PVComplete enables seamless solar design from concept to completion, and we have a whole suite of solar design software, some of which we'll be touching on today. When it comes to utility scale solar project development, careful analysis and optimization to ensure project economics pencil out has never been more critical to mitigating risk, ensuring project bankability, and realizing returns. So the good news is, as solar design software is becoming more sophisticated, developers now have powerful new digital tools at their fingertips to quantitatively inform these portfolio decisions. And as Merce also mentioned, today I'm going to be discussing 7 ways we can now more than ever leverage the software to make some more informed decisions for our utility scale solar project economics. PVComplete's Mega Suite includes 2 tools, 2 pieces of software, PVSketchMega, which is a web-based design tool for utility scale solar design optimization, as well as PVCAD-Mega, our CAD-based engineering tool for multi-megawatt layouts over complex terrain. This suite of tools additionally speak to each other, so you can move from initial web-based optimization to CAD-based engineering and layout seamlessly. The digital approaches I'll be covering, as well as many of the considerations that Miroslav discussed, are reflected in both PVSketchMega and PVCAD-Mega. A little context about our company. PVComplete has been providing solar design solutions since 2015 out of our Oakland, California headquarters. We are also located in Porto, Portugal as of 2019, and we have companies and solar designers using our tool in 44 countries around the world. Across those 44 countries, our customer base includes successful EPCs, developers, and utilities that rely on digital solutions to maximize their time and project economics. So let's take a look at what some of these digital approaches are. Today we'll be considering a specific site. This is 14235 Sample Road, real address. It's a large field with some typical tree lines, roads, and obstructions, and for reference, the site has a rough capacity of 40 megawatts. So first, site prospecting. Before we even think about equipment or configuration, the first consideration is the site itself. Today, there are so many options for accessing digital topography data, and assessing the site considering general slope tolerances allows early assessment of a site's viability remotely. Here at Sample Avenue, we've imported a site image and topography to calculate what we call the rackability, or the percent of usable space based on slope tolerances and other keep out areas. Similar to Miro's example of terrain evaluation and exclusion zones, you can see here in PVSketchMega the 3D profile of the topography, as well as the corresponding keep out areas based on our specified tolerances. So this site specifically has about 516,100 meters squared of usable space, which is 72% of the total plot. We can also evaluate equipment selection, specifically mounting systems, so for both fixed tilt and single axis trackers. With the ability to automate layouts in lightning speed, featuring an unlimited number of different manufacturers, choosing a manufacturer based on which manufacturer and model requires the fewest number of piers or the least amount of steel is now possible. So as we all know, some trackers and fixed tilt systems are better suited to uneven terrain, and creating layouts comparing multiple manufacturers will ensure site economics are maximized. Being able to design for and compare multiple mounting systems extends to both comparing different configurations as well as combining solutions within one design. So here at our sample avenue example, we have on the left our layout, completed layout, and on the right we have specs, pretty small here, but listing things like system size, basic production values, number of trackers, on the right-hand side for different iterations of the design, so we can easily compare basic project specs between projects that are using different racking systems. As Miroslav mentioned, in some instances, different table sizes need to be used together to maximize your site. So with easy configuration and these lightning speed layouts, we can, automatically place tables and trackers and consider different mounting options on one design. This is now more feasible and allows for a better solution that's tailored to the site across the board, both in system capacity as well as project costs. And so speaking of project costs, material costs, this is one of the biggest considerations for project economics. Software solutions can now extend past slope analysis into peer analysis, and this is what our tool does as well. Rather than simply consider a general slope tolerance for trackers, we can now evaluate every single pier. So with automatic pier placement and analysis, every post can be plotted and sized to the requirements of its unique site location and its underlying terrain. So this results in better estimates, less steel, and lower material costs than projects for which all piers are manufactured at a uniform height. The more varied the terrain you're working on, the more impactful this upfront analysis will be. Oops. So in this example here, we actually have an automated pier schedule for a sample avenue from PVCAD Mega. So this calls out each unique pier. And this highlighted column here is the calculated height for every single pier. So basically the sum of that column is all of the out of ground steel you need for your entire project. And so it's specific to the topography and the array configuration. And so this digital approach is also a data-rich approach, which is why it's so impactful when assessing project economics. Additionally, we can also leverage an automated bill of materials to assess material costs. So we can quantify trackers and tables based on exposure categories and size. This BOM example from PVSketch Mega quantifies each unique tracker configuration, so you can quickly assess if projects rely heavily on partial trackers or exterior exposure trackers and other configurations that you might know to add additional costs to your material costs. Because topo and peer analysis allows for a more accurate evaluation of post height, project developers can now determine with certainty how material costs for greater post height and or stronger foundations compare with the cost of site grading, which is again a significant project cost. So we can start by identifying where grading would be required. Here we can see a layout where our earlier site analysis based on imported topography is applied. So automatically we can recognize based on our own qualifiers, the location and size of ground that needs to be considered for grading or adjusted mounting. Additionally, we can see in PVCAD Mega our site layout with analyzed contour lines and affected tables highlighted. In this iteration, we're looking at a fixed tilt system. With this information, you can compute the number of piers that are affected. We can also run peer analysis with adjusted tolerances to assess possible routes to mitigate grading. By identifying problem areas and then considering the piers and tables or trackers affected, differences in costs can easily be computed for a more informed plan forward. Some solar design software platforms make it easy to determine how modifying key system components affect system design and performance estimates. As Miroslav also noted, these key components include modules, various tilt angles, DC to AC ratios, and orientation. We can assess these effects by computing ground coverage ratio, kilowatt output, and capacity and production values. Using software to compute these values is fairly common at this point, but often these calculations are being run in separate and independent tools and requiring a lot of input time and cross-referencing. And so nowadays we're seeing from digital solutions, they're beginning to evolve to actually provide one-stop shops for these key performance indicators. In this instance, we can, and this is an example of this, in this instance, we can select and control project components in real time to see how they affect those key indicators of system performance. In this instance, estimated production. And again, building on Miroslav's note on comparing multiple data sources, we can actually compare outputs from different production calculators. Across our mega suite, we reference PV watts, PVSys, and Canadian Solar's CASIS model. So these can all be referenced directly from our application. And here in the top left, we can see that in this instance, we selected PV watts. And we further defined various modules, inverters, and system losses to assess how they impact that production model as well. Further down the project life cycle is construction. So with automated peer analysis, every post is sized to spec. This eliminates peer height-related slowdowns during project construction, such as on-site adjustments or costly unanticipated grading or custom foundation rework if crews encounter on-site terrain that makes it impossible to install posts within required range as expected. The added accuracy of peer analysis versus traditional slope analysis ensures an elimination of false positives that affect on-site construction, as well as false negatives that cause lost capacity to your initial design. Additionally, we're seeing more and more 3D renderings of solar designs these days, and the ability to view the elevated project in a 3D profile provides context to crews before even breaking ground, so there's no costly surprises once at the site. In PVCAD Mega here, we can see the 3D profile, and harder to see in this small image, but we've actually all the little yellow in there. We've placed every single pier on this sample avenue design with unique pier heights, and it's applied to every single pier. So as we saw earlier with the pier schedule, all of these heights are actually recorded for easy reference and use as well. And the last point I want to wrap up with is discussing optimization. So much of what we've discussed so far is some form of optimization. New automated software can take us even further down this road by doing the heavy lifting for us. Instead of manually recording and comparing all the outputs for separate production calculations and layout tools, software can now consolidate all of this information in one place, so we can succinctly run and compare all possible iterations in one place. For large-scale projects where designing for every possible outcome is unrealistic, this is a game changer where designers can now pick configuration based on target system size, kilowatt-hour production, or levelized cost of energy. And so here we can see optimization results directly from PVSketch Mega based on our preferred project goal of 40 megawatt system size and limitations based on ground coverage ratio and tracker configuration. Every possible outcome is auto-calculated and displayed in the table below with project specs. And in the graph above, each dot on the chart is a layout using a different GCR or mounting system. So for easy visualization of how the different configurations stack up against each other. Any of these configurations can then be rendered and viewed automatically to help teams move on to the next phase of project design. So in conclusion, we are now in a time where we can leverage digital approaches for site prospecting, mounting system selections, material costs, grading, system GCR, kilowatt and kilowatt hour, constructability, and optimization. As solar projects become larger and installed in increasingly varied terrain, these approaches are necessary to realize return and maximize project economics in an increasingly competitive and growing industry. The world of solar software is still young, and so we are all looking forward to the innovation that will continue to help us push solar across the solar industry. Thank you.
Thank you very much, Olivia. And also thank you very, very much, Miroslav. Your presentations were very insightful and also informative. And now I believe that we can move to the Q&A session. So Miroslav, if you would like to open up the camera so we can see you. Okay, now. So while you were presenting, we have been receiving a lot of questions from the audience. So now I'm going to bring some of them to you. And I believe that the first one may go to Olivia. So Olivia, the audience wants to know what's the added value, what is the competitive advantage of PVComplete compared to other simulation softwares?
Yeah, great question. So, you know, I think the keyword there is compared to other simulation tools. So PVComplete is really a design platform. And so we're working on not just production estimates, but as part of a larger picture of design and optimization. And between PVSketch Mega and PVCAD Mega, it really covers early stage sales and optimization all the way through CAD engineering-based construction plan set. So it really is a full platform, and as I said earlier, that one-stop shop, not just for design, but for optimization as well. In that sense, it does stand aside from a lot of other products in that, and especially also that it's in CAD. There aren't many products out there that integrate with CAD, which is a well-known and used tool across engineering departments.
Nice, thanks. And related to this question, also we would like to know what is the system science range that these digital approaches and tools work with?
Yeah, great question. So I would say 1 megawatt all the way up to 1 gigawatt. It's really built with these large projects in mind, and some of the customers that are using our tools today, they're coming to us with questions working on their 600 megawatt project. So it really is any kind of utility scale project, and built to handle these larger design challenges.
Nice. And I believe this question may be for Miroslav. What do you think that is the cost versus efficiency gain that we can expect from a bifacial system?
Well, yeah. What I can say, like general numbers, it was also partially visible in the presentation. The efficiency, let's start with the efficiency. The efficiency that we usually get from the bifacial modules, depending on the location, respectively the albedo, is, let's say, in the range of 5%. In my slide, I was showing something like 3-4%, but it is with a low albedo. So let's say that 5% is normal to expect in terms of more yield from bifacial modules. In terms of cost, I can comment only the current situation because it's a really dynamic market. But the cost difference is really minor at the moment. I would say it's less than 1%, and it is going even lower. I mean, the bifacial technology is new for the market. It needs to prove, but the tendency seems to be that in the future we will not be discussing yes or no bifaciality. Bifaciality seems to become a standard, market standard.
I see. Thank you, Miroslav.
Thanks.
And also, I was wondering what typography sources do these tools consider and analyze? And I believe that question may be for PVComplete.
Yeah, thanks for that question. So it's twofold. First of all, we can provide it for you through Google Elevation Services. It's point cloud format, available for all sites, automatically imported. But we also are able to work with your existing topography. So contour lines, point cloud, you can use your tried and true topo sources and we can analyze it for you.
And I believe that the results that you provide, are these validated with on-site measurements?
Well, the topo information is from Google Elevation Services. So we do typically find those points can be a little bit less dense than third-party topography sources. But again, it just depends on the company's need and the project situation. For early stage design and early consideration, or sites that you're not able to find those resources for, it's a really strong fit. For others that have something that's more tried and tested and a little bit more dense and points wise, that's why we have the other option.
Very good. Also, there were questions related specifically about the terrain topography data that is coming from PVSketchMega, right?
Yes.
Okay.
That is again, that's Google Elevation Services. So all imported topography automatically is Google Elevation Services.
And also we are receiving questions regarding the meteorological data.
Really great question. So it does depend based on what production calculator you're using. But generally speaking, PV watts, which is the most standard and basic across all of our products, it's a product by NREL here in North America, and we use NREL weather files for North America, and any international locations we're pulling meteor norm files. PVSist, what we're really doing is exporting your 3D shade scene into it, so you'd still be using typical weather files that you'd usually use with PVSist. So it really depends on the calculator you're using.
Perfect, thank you. And this is not a very technical question, but also I understand it from the customer point of view. Is this software available in English only, or maybe translated to other languages?
Yeah, currently everything is in English only, but as I mentioned, 2019 we finally made it across the lake into Europe, so we do hope in the future to expand resources in other languages, but yes, currently everything's in English.
Perfect. And Miroslav, you mentioned that you believe that the actual trend will be that we see all systems to be bifacial. So, right?
Yeah, again, to predict the market, it's really difficult.
That's very difficult. I'm not going to ask you to predict the market.
But this is what the reality is showing. I mean, especially because this is the first part of the question that you asked me, or somebody from the audience was asking. It's really a matter of comparison between the gain that we are receiving from the technology and the cost that we are paying for this. So as soon as this comparison is showing positive results, it is most logical to expect that it will be the current trend. So yeah.
Thanks. And both of you, do you, for instance, to calculate the energy yield, to estimate the energy yield, is it based on statistical data or is it based on probabilistic data? Maybe too technical.
If you want to answer that first, Miroslav.
Yeah, okay. What I can say is that I was showing 5 different sources that we are using. Of course, part of them are free data sources. Other ones are that we pay for this, of course. It really depends on the location. What I can say, of course, it is always to use a data source that is based on real measurements. Right. But it depends on the location of the project. So if this is the situation in the country that there is real data available, of course, always let's go for this. Then when it is not, of course, we are going to synthetic data and probably looking for sources which are third-party validated.
Yeah, and similar to my response before, you know, we're pulling data from Google and known weather files, but if that doesn't serve your purposes specific to your site, it's hard to answer that without knowing what the location is. We have many different facets where you can import and use your own data.
I see. And also, does PVComplete provide training to know how to use the software?
Yes, we do. So on our website, we do hold weekly demos, so you're welcome to come have a whole walkthrough of PVCAD-Mega. And PVSketchMega is actually a newer sister tool that we're launching in conjunction with PVCAD-Mega. So It's on its way the end of this year, and we have a few more kind of sneak peeks that are happening, but all that information can be found on our website, PVComplete.com.
Nice. And Miroslav and Olivia, normally do you also take into account the soiling effects in your calculations, in your estimations?
We do. So under the energy production calculator that you pick in PVSketch Mega, there's a place to define soiling and things like that. And again, it really just depends on the calculator. Things in PV watts are very simplified versus CASIS or PVSys is much more detailed. So yes, there are spaces to define that. The level of nuance depends on the calculator you pick.
I see.
Yeah, I can only add that yes, of course, also in the software that we are using, there is a point for defining this. But in addition, I want to say that we are also doing our own, let's say, investigations based on different criteria to define the soiling factor values which we use in the different countries where we are active. Again, having in mind that basically in the countries where we enter, we are entering for a long time. So it makes a lot of sense to run such a project of evaluation and estimation to have a more accurate idea about the factors that the soiling factor depends on, and to have more precise values for this factor. Yes.
Perfect. And all these simulations, do they also consider the local permitting request, or this is something that would need to be made like after or in parallel?
Oh man, I wish. Yeah, I mean, permitting is a big undertaking for anyone that's working on these projects. And what makes it especially hard is that it's different everywhere. And so I think that would be a whole nother tool in itself to compile all those requirements and allow you to design according to that automatically. So unfortunately, no. We leave it up to you to understand what your project requirements are and then design for them. And especially in the CAD space, very flexible. CAD is just a super versatile, robust tool. So we give you all of the spaces to adjust for those requirements, but you have to know specifically what those requirements are based on your site location.
And I wonder, or if you could elaborate, please, what is the relationship between these tools and software with, for instance, designing or optimizing operations and maintenance strategies later?
That's a good question. So I would say all the data we're pulling is before installation, and so when you look at operations and maintenance, it's a lot of pulling real-time information from an already installed site, and we don't really deal with that. So that's kind of where our cutoff is. Once you've put the project in the ground, we don't have any place to input and continue to monitor or collect data for that existing project. Certainly, if you collect information from past sites that you want to use in application for designing new ones in consideration, there are some ways you can do that, especially through PVSys and other things like that. But we really focus on the life cycle of the project before it's going into the ground, and a little bit during, in my point about construction and mitigating those false negatives and on-site changes. But yeah, mostly design and before in the ground phase.
Okay. And Miroslav, I also wanted to know about you, about this approach.
Yeah, I could say a few words in addition to this, what Olivia is explaining, especially again, having in mind that ABO is also providing O&M services for a big number of the projects that is executing. I can say that the O&M issues are addressed outside of the environment of the software too. I mean, there are a list of criteria, for example, or recommendations or requirements that the O&M team can set, and this to be implemented in the design decisions that are made. But yes, this is the the only way for smooth O&M if the criteria and the recommendations are considered in an early stage of the design. And this is also related to the financial parameters of the project, of course, because very often we are talking about transferring costs between CapEx and OpEx, but at the end it goes together for one project.
Okay. And I have been also receiving questions regarding drones, which are used for inspection of the plants. So I don't know if there's some sort of like data sharing between these tools and these new, say, devices, like the drones that are used for inspection.
That's a tricky question. I mean, our tools specifically are unique in that we do share more project information across tools across the platform via APIs. So it's not completely unrelated, but that's just another level of integrations with, you know, drone providers and things like that that is a little bit out of scope for us. You know, we're pulling from existing databases or allowing you to manually input information. Pulling and partnering with companies that do that would be amazing, but it requires a lot of partnership from both sides, and so it's tangentially related, but not directly in the scope of kind of what we're doing.
You may be open to these partnerships.
Yeah. If they reach out to us and it sounds like we could really feed a need in the industry, we're always open to it, but we really do focus more on the design features of it and the assessment of that design rather than collecting the data.
Perfect. I also have already received the comment saying that partnerships will be key.
Yes.
Perfect. So another question from our audience is in your tools the user the ones that input the OpEx and CapEx costs, or these are estimated from typical values?
For like levelized cost of energy, those things?
I suppose, yeah.
Yeah, and these are actually feature sets that we're still building on and improving on right now. And so right now at this point, because you could put a lot of information into calculating that number, we are looking at a more generalized format, kind of rule of thumb method. And so it would be based on a goal that you put in, what you want that to be, and our calculations to match that in your system performance would be based on generalizations.
Perfect. And well, we will have 10 minutes. Before closing, I actually would like to invite you to provide just one message that you want the audience to listen, to understand. So from your perspective, considering that actually taking a digital first approach for the design of these utility scale plants would be key for the future, but also for the present. Actually, what would be your recommendation for the members of our audience to consider if they want to also utilize your tools, or they are thinking about also working in this type of environment?
I mean, obviously I'm a little biased, but I think across the board, any company that is trying to maximize their time and accuracy is investing in software and these digital approaches, whether that's native tools that they're building out because they're a really large company, or a smaller company that's investing in off-the-shelf products like the one we and other companies provide. And so it's really at this point not something that is like, oh, it would be nice to have, to keep up and really get the most out of your project design. And, you know, after the projects are in the ground, it's really something that you should be looking at now and thinking ahead of how your company and team can grow into using these tools. And obviously on our end, because we do provide a wide breadth of tools across different kinds of solar installations and usability for different teams, whether it's sales or engineering, I would recommend going to our website and checking out, especially for utility scale, the Mega Suite, just because it is comprehensive in that there's something for everyone. It's usable across the whole department and all parts of that design process.
Thanks, Olivia. And Miroslav, from the Apple Wind perspective?
Yeah, what I can say is try to assure flexibility, because the industry is really dynamic, and flexibility I think is from key importance. Also stay open-minded, again for the same reason, because the industry is dynamic and the technology and the market is changing rapidly. So to stay on track, we need to be flexible and open-minded. And unfortunately, for me, the experience that we get in the last 1 year, let's say, it is not necessary that will be applicable in the next 1 year. So do not rely that much on common practices. Stay open-minded and be flexible and be prepared.
Stay open-minded, flexible, and prepared.
Yeah.
I think that these are beautiful remarks.
Thanks.
Perfect. So now what I would like to just, before closing this webinar, who has been amazing, and thank you very much for your knowledge and your inputs, which based on the questions that we have received, we are like beating records. So this has been a very well accepted webinar. So thank you very much. And before the closing remarks, before saying goodbye, I just would like to end up with some information for our audience. And it's just to inform them about the SolarPower Europe's webinars. As you may see here, we have 4 webinars in the list that you can tune in if you want. And also, of course, you may have online visibility opportunities if you want to, in the form of these webinars, podcasts, newsletter, online reports, and executive interviews. And as I said before at the beginning of the webinar, you can access it, the recording, once we finish, that we will be uploading on our website, I believe, and also shared in our YouTube channel. So also, please feel free to reach out to Miroslav and to Olivia if you have more specific questions about their presentations. So just don't hesitate to get in touch with them directly. And now, yes. So I'm going just to close up this webinar and say thank you, Olivia and Miroslav, again for your time and for your knowledge. And I wish you a very good evening and a very good day for you, Olivia, who is joining us from the East Coast.
Thank you too. Thank you, Merce. Thank you, Olivia. Thank you, everybody. Stay tuned.
Thank you both.
And
Thank
keep
you.
safe.